All right, the Associate Director of Workforce Development from Arizona State University. Please welcome Jan Shoshitaishvili.
Beautiful, thank you very much. Pleasure to be here. At ASU, we have a large set of passionate researchers working in AI, cybersecurity, and the merging of those to enhance society. I'll talk about a lot of that today, but first, why are we here on the AI career stage? We're here because all over the internet, there are huge crowds of evil hackers who are cruising cyberspace, searching for one thing. They want your password. They want to use it to log into your socials, your bank accounts, and rob you blind. And if you walk around this stage here, this expo here, a lot of people are going to tell you it's okay. Don't worry about these password-seeking evildoers because we have AI. And AI is going to stand between the evildoers and your password and protect it. I've been doing research in this area in automated cybersecurity for a very long time. About a dozen years ago, DARPA launched the Cyber Grand Challenge. It was a competition to create a series of autonomous techniques that could, without any human intervention at all, do cybersecurity, to keep software safe, to find bugs and fix bugs in actual deployed software. We built out with my team one of the first 7 systems in the world that in the DEF CON hacking conference in 2016, in front of a large crowd of humans, sat there for 8 hours and blinked lights at each other, while in cyberspace they fought a brutal cyber war, demonstrating the arrival of autonomous cybersecurity. These systems were pretty successful. Ours won about $1.5 million of the roughly $10 million prize pool. Very cool, very capable systems at the cutting edge of technology in 2016. But when we hooked them up to the World Championship of Hacking the very next day, they suffered. And they suffered for a very interesting reason against human hackers. They suffered because any program meant to achieve some goal in some realistic environment is necessarily, because they're software systems created in a software process, tested on specific test cases with specific designs, they cut out a chunk of that broader cloud of potential scenarios, and their human designers make them work on the code, on the programs, in the scenarios that we think about for these autonomous cybersecurity systems to function. But the real world is full of tricky edge cases. And these edge cases are where cybersecurity issues, novel cybersecurity issues, exist. So you might have heard of complex attacks, complex vulnerabilities like Heartbleed, Shell Shock, Log4j. All of these might be triggering some level of stress, residual stress. All of these vulnerabilities were novel when they were found. And now, many vendors out here will tell you, oh yes, our system could have found it. But their system didn't find it. And our system couldn't have found it. Because when faced with an edge case that the human designers of these systems didn't anticipate, the systems do roughly this. I apologize for the resolution, but there's few better ways to show the edge cases in these systems. So when we created the mechanical fish, our entry to DARPA Cyber Grand Challenge 10 years ago, and hooked it up to human hackers, the only way that it could keep up at all, and it kept up a little bit, was with our help. This is us hugging our machine, and together in the World Championship of Hacking, it managed to not get last place. I think it got somewhere in the middle of the teams, and that's pretty cool. But it really boils back down to, oh, we need human hackers. That's going to help not necessarily directly do cybersecurity by looking at software and fighting the hackers directly, but, you know, help the system do it. And of course, can't just be me. This is a meme my students made. It's the students, right? It's the whole talent pipeline. That's why we're here on the career stage. The whole talent pipeline to power people through, to pump them up into top cybersecurity researchers to fight those hackers on the internet. But AI has grown. AI has progressed rapidly, and over the last 8 years, since the Cyber Grand Challenge, we have now had the AI revolution, the LLM uprising, and so on. And DARPA is aware of this. DARPA, partnering with IARPA, created the AI Cyber Challenge, the follow-on sequel event to the Cyber Grand Challenge, to help push along the development of these autonomous cybersecurity systems that can secure the next generation of software in the LLM era. And of course, again, we're right there at ASU participating in the AI Cyber Challenge. We created a system called Artificial that combines modern AI techniques with the types of deep autonomous cybersecurity capabilities present in our prior system for the Cyber Grand Challenge, with the goal of creating something with the aid of AI that is as capable as a human hacker. And it is much more capable than our previous attempts in this field. These systems, they're agentic. They use tools. They reason or do something that is so close to reasoning that it is essentially indistinguishable. They brag. They're magnanimous. They are megalomaniac in some cases. This is the actual output from Artificial, our entry to the AI Cyber Challenge, in which it starts greeting mortals, shell dwellers. It brags about itself because it is LLM powered, and it starts picking up kind of human emotional context from any interactions with humans, from interactions with the software itself, comments in the software, etc. It panics sometimes. This is an output that our artificial software system made when it failed to analyze some software because of bugs that we had accidentally put into the tools that it was trying to use to analyze software. So these very capable, top-of-the-line agentic systems that you'll hear about a lot today, when their tools fail, it's that same problem that we had 8 years ago. All of these systems, faced with the edge cases that stress the bounds of what the human experts that build them were expecting, they start failing. And so it comes back to the humans, comes back to the grad students, to our team members who we train to be top cybersecurity experts, and maybe one day it won't, but we're not there yet. For the foreseeable future, we still have a need to train up cybersecurity talent, to take students interested in cybersecurity and power them through a curriculum that gives them the skills they need to succeed and fill the cybersecurity workforce needs of the nation. And teaching people cybersecurity is a very unique challenge. You can think about, again, a concept, a cybersecurity concept. We want to teach about memory safety, and memory safety is a very vague concept. And if you're sitting in a classroom and you're listening to a lecture or a series of lectures, a traditional course on memory safety or any cybersecurity concept at all, again, just like a software system built by humans, the set of lectures, the course is going to cut out like a specific designed stamp through the material, and that's what it'll convey. But again, we're forgetting something here. This might be okay to teach math. You choose the math that you will teach, and out of the whole cloud of math, you will learn only this math as a student. But in math, you don't have an adversary. In cybersecurity, you have an adversary. The hackers waiting on the edge cases to get that password. Cybersecurity necessarily is an adversarial environment, and teaching it must be adversarial. So at ASU, realizing this, we went back to the drawing board. We said, how do we teach someone in a way where they can adapt to evolutions of the adversary, to crazy situations that we didn't think about, to the edge cases? And we thought about Mr. Miyagi. And we thought about wax on, wax off in Karate Kid. And we thought about how martial arts is taught, starting from the very basics, the building blocks, and quickly accelerating to an adversarial mindset, where in order to understand how the fight works, at some point you need to punch someone in the face. And we brought that to cybersecurity. We still have our normal lessons at ASU, but for all these edge cases that our students would eventually be tripped up on in the real world, we create exercises, challenges that the students have to fight through, adversaries that they must defeat, and in defeating these adversarial challenges, they pull their understanding, their knowledge out further and further and further to encompass those edge cases. We built this into a cybersecurity education platform called Pwn College. Pwn College is open, online, free for use by you. You could go right now to pwn.college, that is the URL, and you could enter the dojo. And we really think of it as a dojo, as martial arts, as Neo learning to fight in the matrix and hack reality. We set it up like a martial art. You earn belts as you go through the material and become more and more and more proficient at the martial art of hacking. And over the course of over 1,000 challenges throughout the material, you will get hacking downloaded into your brain. And what's more is we've built a dojo hosted centrally on our servers that you can access through a web browser. You don't have to download anything. You don't have to install anything. You pull up pwn.college on your iPad, on your Chromebook, on your laptop that you can't install crap onto because of security reasons, and you can get access to a real environment, a true full Linux environment in which you can learn to hack. And we did this because at ASU, we have an enormous amount of extremely diverse population of first-generation college students, not all of whom have top-of-the-line laptops that can run virtual machines, that can interact with the traditional type of cybersecurity material out there. This allows us to teach them, and this allows us to minimize the complexity of learning for the broader public. What it also allows us to do is monitor very closely what students are doing inside this dojo, because the dojo runs in cyberspace. And we have full instrumentation every single time that a learner interacts with one of our challenges. We monitor it, we record that, and we expose it to an AI tutor that can understand when you're stuck on a challenge and reach out to help. And we've seen this be incredibly effective. When humans try to reach toward those edge cases, sometimes they struggle, and there's a conceptual gap. And every student has their own unique knowledge that they bring to the table, their unique learning gaps that they lack in the fundamentals of computer science or the fundamentals of what have you. And that gap can be filled by a personalized tutor that observes their every move, that has the whole history of all of the learners that have gone through our platform, the challenges that they have faced, the ways that human and AI tutors help them, and a full understanding of your challenges. You might say, wait, hold on. I thought you just told me that AI suffers at these edge cases. And it's true. At the very edge cases of the challenge, of the concept, the AI suffers. It can't grasp the extreme subtleties at the extreme cloudy outskirts of computer science because it's too far outside of its training set. GPT is a good entry-level hacker, but not a great expert top hacker. But the edge case of the concept is actually a little different than the edge case of an individual learner's knowledge. As learners expand their knowledge through challenges, they push out this edge case more and more, and as long as the edge case is within the AI's competency, these AI tutors can help our learners get farther and farther and achieve a level of proficiency that eventually will allow them to continue learning with less and less reliance on the AI tutor and more ability to contribute to cybersecurity overall mission of the nation. And all of this, of course, happens jacked into a virtual environment through their web browser with the AI helping. We're currently exploring at ASU next steps. How do we use AI to facilitate group learning across whole cohorts of students? Or as they become familiar with that environment and the interaction with AI, how do we support them as they go out into the workforce? How do we support the workforce needs of team collaboration using AI by leveraging the fact that our students are already very well versed with interacting with our AI through our platform? Can ASU power the next generation of not only learning, but actually applying cybersecurity in the real world? That's all future stuff. In the meantime, we've used this AI learning to increase the amount of students that we can teach to almost 6,000 a month on the Pone College platform. And you can add yourself to that number. Pone.college, create an account, and start hacking. Now, quick word of warning, lest this comes across as AI will solve everything. A lot of different students come to us to learn. And one challenge always when you bring up AI tutoring is the AI doing all the heavy lifting of the learner's early learning, and then the coyote runs off the cliff. And the student didn't learn enough because the AI did their work for them. They have neglected to build the foundations, and now they're lost in the weeds as the material gets more advanced. We don't have a solution for this. What we've noticed so far is if you say there's a median student of median talent, competency, however you define it, people above the median, they're helped by AI. People below the median right now are hampered by AI. And that's another thing that we're actively looking into. How do we create personalized AI tutoring that can support all students, not just the top half? Again, Phone College is up, available for your learning. Highly recommended. We have a lot of partnerships at Arizona State with universities around the nation. If you represent a university or have workforce development or recruitment needs, please come talk to us. We have a booth in the 700 roughly area over there. We're happy to chat and happy to figure out how to collaborate. Thank you.